So now we have a paragraph type problem over here, and the paragraph is from question number 11 to 13. A small block of mass capital M moves on a frictionless surface of an inclined plane as shown in the figure. The angle of the incline suddenly changes from 60 degree to 30 degree at the point B. The block is initially at rest at A. Assume that the collision between the block and the incline are totally inelastic. So the problem that are asked is the speed of the block at point B immediately after it strikes the second incline. The next one is the speed of the block at the point C immediately before it leaves the second incline. And the last part is if the collision between the block and the incline is completely elastic, then the vertical component of the velocity of the block at point P immediately after it strikes the second incline is. So if we start dealing with this particular paragraph, so we are saying that as the inclined plane is frictionless, we say that the kinetic energy at D is equal to potential energy at A. So if we say something like this, so if I draw this portion of the incline, so this one is equal to 60 degree. Over here this is equal to root 3 meter, and we are considering this as a height h. So we will be over here at a point A, and this is point B, which is the lower end of the incline. So we can say over here that kinetic energy at B is equal to potential energy at A. So kinetic energy at B can be written as half mv square, which is equal to potential energy at A, that is equal to mgh. So over here, in order to calculate the value of h, we are simply using tan 60 degree, which is equal to h by root 3. H by root 3. So from here we get h is equal to root 3 into 3, that is equal to 3 meter. So if I put this h over here, so I will get the value equal to half v square is equal to g into 3, that is equal to 30. So v is equal to root over 60 meter per second. So this is the velocity of the block just before the collision. Now this velocity over here, so if I draw this, so it reaches over here and it is moving with this velocity v, which we have calculated. So now at this part, if I magnify this diagram, so I am saying something like this, that if we look at this particular case, it is something like this. So at this point the velocity is directed like this with a speed v, and it makes an angle of 30 degree with the vertical. It makes an angle of 30 degree with the vertical. So I can say that this angle over here is equal to 30 degree. So the velocity of the component along the incline, that is BC, remains unchanged, and this will be equal to V cos 60 degree. Sorry, V cos 30 degree. So this is equal to 30 degree, and it will become V cos 30 degree over here. So at this point the velocity component along the incline BC remains unchanged, and it will become equal to V cos 30 degree. So over here we can calculate it as root 60, and cos 60 degree is equal to root 3 by 2. So from here we attain a value equal to root over 180 by 4, that is equal to root 45 meter per second. So if we look at this problem, it is stating the speed of the block at a point P immediately after it strikes the second incline. So it is going to be equal to root 45 meter per second. That is option B is correct for this particular problem. So as it strikes over here, it is also indicated in this diagram. So this angle is 30 degree, and this component will become V cos 30 degree. And it is also because of the fact that it is given that the collision at B is perfectly inelastic, therefore the impact forces act normal to the plane, such that the vertical component of velocity becomes 0. So the vertical component of velocity will get nullified, it will become 0, but the component along the incline will remain as it is, that is we get value equal to V cos 30 degree. Let us deal with the next problem. So the next problem is stating the speed of the block at a point C immediately before it reaches the second incline. So in this particular case, we are dealing with it in this way. So if I again come back to this diagram, so over here it is equal to BE, we are making this point as equal to E. So if I say in this triangle, if I say in the triangle BEC, so I'll be drawing this triangle in the other page, kindly take a note. BEC will be drawn, this is 3 root 3 and this is equal to 30 degree. So if I draw this triangle over here, that is BEC, so this is equal to 3 root 3 meter and this angle is equal to 30 degree. So if we apply tan 30 over here, so we say tan 30 is equal to BE by CE, that is equal to 1 by root 3, which is equal to BE by 3 root 3, and we attain a value equal to 3 meter. So if we apply mechanical energy conservation at B and C respectively, so I can say energy conserved at B and C respectively. So now at B the value of velocity is calculated as half m root over 45 whole square, half m v square, plus equal to mgh, that is m, g is 10 into 3, which is equal to half m velocity at c squared. So from here I can chop out all the m, and from here we attain Vc as equal to root over 105 meter per second. So for this particular problem we say root over 105 meter per second, or option B is correct. Let us deal with the next problem. So if the collision between the block and the incline is completely elastic, then the vertical component of the velocity of the block at a point B immediately after it strikes the second incline will be. So now the velocity of the block along BC just before the collision is V cos 30. That is, if I draw it one more time. So this is how the inclined plane arrangement is looking like. So just before the collision over here, we say that this velocity V can be written in this way: V cos 30 and V sin 30 respectively. So if the collision is perfectly elastic, then I can say that the velocity can be broken in this way in the two component. The impact forces act perpendicular to the surface so that the component of velocity along the incline remains unchanged. So the component of velocity along the incline, that is V cos 30, remains unchanged. Also, since the collision is elastic, the vertical component, that is V sin 30, before the collision changes in direction, the magnitude remains the same as we have marked in the figure. So the rectangular component of the velocity after collision are as shown in the figure. This means that the final velocity of the block should be horizontal, making an angle of 30 degree with BC. Making an angle of 30 degree with BC over here. Therefore, the vertical component of the final velocity of the block is 0. So the vertical component of the final velocity of the block will be 0 in this particular case.